Hi, I am Rohan Sutradhar and my team member is Prathma Sarkar, so we are making a major project on improving symptom extraction and identifying medical experts from the medical transcription. First of all, we import the necessary libraries in Google Colab such as NumPy, Pandas, NLTK, Matplotlib, Keras and others. After that we have installed joblib. Then we read the CSV file and print it with train.head. We can see that there are 6 columns. Using train.tail we can see that the CSV file consists of 5000 rows approx. Then we have done train.info to get the information about the dataset. We observe the standard deviation, mean, and count of the dataset. Here we have done the pre-processing of the data by removing the unnecessary numbers, symbols and alphabets. And also make the necessary adjustments by using the full form. Hence also cleaning them through our function. Now the cleaning is done. So here we are making a new column that is text new which consists description, sample name, transcription, keywords. Here we are observing the value count of the medical specialty such as surgery is 1103, orthopedic is 355. So here we have plot a bar graph of the medical specialty and noticed that there are many classes which have less than 50 count, so we have to remove them one by one. Here we have removed the classes which have less than 50 value count. Now we can observe that the bar graph is better. Now we have found that there are null values in transcription and keywords. So we have removed the null values. Now the shape of the dataset are 3398 rows and 7 attributes. Here we can see the unique values of the medical specialty. Now we are giving the value for each class of the medical specialty 0 to 18. Here we can see that it is providing the number. Here we are getting the unique value for the medical specialty. Now taking X as text new and Y as medical specialty. Here we have done the train test split with test size 0.2. After that converting dependent variable into categorical variable. Here we have convert to text to sequences using tokenizer in which we have taken vocabulary size as 20,000, lower as true and UF token as UNK then fitting on texts. Here, xtrain is a set of training data containing text. The tokenizer is fit on this data, meaning it learns from this data to assign unique numbers to each word. Then we have taken padding's max length 300 and taken as postfix. Here this line of code saves the tokenizer object to a file named tokenfinal.pkl using the joblib.dump. Now making the model, here we have used sequential model. Sequential model is a linear stack of layers. Here in embedding layer we have used vocabulary of 20,000 words, input sequences will have a length of 300. Here we have used dropout as 0.5, dropout is a regularization technique used to prevent overfitting. In next line adds a bidirectional LSTM layer to the model commonly used for sequence processing tasks like text analysis. Another bidirectional LSTM layer with 128 units, again dropout layer of 0.3, the adding fully connected, dense, layer with 128 units. Then in the next line adds the output layer with 19 units, each representing a different class in the classification task. The activation function used here is softmax, which converts the raw output scores into probabilities, making it suitable for multi-class classification problems. Then we have used Adam as an optimizer, the loss function, categorical cross-entropy, suitable for multi-class classification, and the evaluation metric, accuracy. We can see that in the output we get total params as 6.27 MB. Importing Keras and TensorFlow. Here we are plotting the model. Now we are running the epoch for 500 times. We are getting the accuracy as 98.64%, which is great. Now saving the model. Here we are plotting the graph. The first graph is accuracy versus epoch. The second graph is loss versus epoch. Here you can see the classification report for every class. We have also created the confusion matrix. Here is the confusion matrix. This is the heat map. This is also a heat map with line spacing. Here we are looking at the multiclass's unique labels. Now combining these labels with the confusion matrix. Now plotting actual versus predicted value for each class. Now, doing same plotting as above but in heat map format. Now we are loading our model. Viewing the model summary. Now we are taking the user input. Loading tokenizer, then we have done text to sequence, after that done the path sequence, now our model is predicting. Viewing the shape of prediction. Model is passing the argument of predicted value as 2. Cardiovascular pulmonary. That is our result. Here we have done the same thing in short version of coding. Now in the command prompt we will give part of our project, we have used Streamlit framework. This is the simple interface. Here the user can write the description, then click on the submit button, the user can view the result. We are getting the result as cardiovascular pulmonary. Thank you.